Today we're going to look at lesson 4-2, day 1, and it's over quadratic functions and vertex form and looking at the transformations. So here we have the graph of a quadratic function is commonly called a parabola. And I apologize, but I'm still sick, so my voice is terrible. When we write a function in the form of f of x, which is y, equals ax squared plus bx plus c, this is known as standard form, where a cannot be 0. This is known as a quadratic function. But when any quadratic function is written as f of x is equal to a times x minus h squared plus k, where a cannot be 0, then we will say the function is in vertex form. So this is one of the most useful forms for graphing. So we'll look a lot at vertex form. Also, this is called standard form. So standard form and vertex form will be important. And you'll notice from our work with radical equations that if we are graphing our parent graph is this right here, basically y equals x squared. The a would just mean if it has a stretch or a shrink. So x squared is our function. So notice that here in vertex form, it's the best form for us to see our transformations in. So for instance, if you're adding or subtracting something inside the function, that's your right-left movement. If you're adding something or subtracting something outside the function, that's your up-down movement. The coefficient, or the number in front of the function, is where we stretch or shrink. And remember, if a is greater than 1, it stretches. If a is between 0 and 1, it shrinks. And then if a is negative, it's going to reflect over the x-axis. And so in this case, because it's a quadratic, normally it looks like a parabola opening up or down. If a is positive, meaning greater than 0, the parabola is going to open up. If this a is negative, then the parabola will open down, and you'll see a curve going like this. The line that divides the parabola into two mirror images can be found in this form right here as x equals h. So it's basically, if this is, look at the graph below here, if this is the parabola, this right here would be the axis of symmetry. It's cutting that parabola in half. And this point right here is the vertex. And that vertex is going to be known as h comma k. So h is going to be the x value of the vertex, which makes sense because this h is our right-left movement, and the x-axis goes right-left. And then k is the y value of the vertex, and that's referring to this k here, which makes sense that would be y because that's our up-down movement, and the y-axis is up and down. So this axis of symmetry is a vertical line that goes to the x value of the vertex. So remember, it's always x equals because it's going through the x-axis at that x value. So it will always 100% of the time go through the vertex. And so it's always x equals the x value of the vertex, so that's why they're saying it's x equals h. And it is known as the axis of symmetry. Another important feature of vertex form is that we can find the vertex of the parabola where the axis of symmetry intersects the parabola at the point. And they're talking about this point right here. So as you look at this vertex form, the opposite of h, because you know it says a negative here, so think negative, okay, it means the opposite. So the opposite of whatever this number is here, because notice we have h, so that's the opposite of negative h is positive h. It doesn't mean this is positive, but if this number here is a plus 2, then our h will be a negative 2. If this value here is a minus 2, then our h will be a positive 2. So it's always the opposite, just like our movement's the opposite here, and then exactly what you see here. And so that value that they want here should be h comma k. Okay, so we've already identified key elements. Now typically, this is not our parent function. The parent function would be here. So let me draw in the parent function. The parent function would be here, 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 and like here. So this would be the graph of our parent function, y equals x squared. And so typically for the parent function, we use the following values for x: -2, -1, 0, 1, and 2. So if you take -2 and square it, you get 4. So this ordered pair right here is 2, 4. I just estimated it there. And then -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So those are generally the points that we'll choose. Now, if I have a stretch or a shrink, we're going to be using a table of values to graph these parabolas. Only if I have a stretch or a shrink or a reflection. But if all I have is up, down, right, left movement, I am going to plot my parent function first and not connect the dots, and then just move those points right, left, up, down. But as soon as I have a shrink, stretch, or a reflection, then I'm going to be using a table of values. And so we typically will choose these values for x unless there is a right-left movement, because right-left movement affects x. And so we'll use that right-left movement to determine what values here we should choose. So let's do some graphing. All right, so let me make this bigger. Okay. So we are going to graph y equals 2 times x squared. So this is the function is x squared. So nothing is being added or subtracted inside the function or outside the function. So this is considered a. Because a is greater than 1, I have a stretch. So you might want to write that you have a stretch. We are going to find all of these values here by doing a table of values because I have a stretch. Because I don't have any right-left movement, I am going to choose the normal values for x: -2, -1, 0, 1, and 2. Now, depending upon what a is, this value here, I might adjust these values because sometimes I'll get a fraction, but fractions really aren't that hard to graph, so it doesn't really bother me if it doesn't bother you. All right, so we're going to put -2 in here. -2 squared is 4. 4 times 2 is 8. -1 squared is 1. 1 times 2 is 2. Then 0, right here, 0 squared is 0 times 2 is 0. And then we're going to take 1, square it. We get 1 times 2 is 2. And then finally, 2 squared is 4 times 2 is 8. Okay, so I'm going to plot for you the parent function. So the parent function is here at 0, 0, 1, 1, 2, 4, -1, 1, and -2, 4. Okay? Now, I'm not going to connect those dots, but I just want you to see that that would be the parent. Actually, I will connect it for this one because I want you to see the stretch. So I'm going to put a dotted line to show it's not really the function we're looking for. So that's the parent function, y equals x squared. But we are going to graph this function right here. So let's graph those ordered pairs. So -2, +8, -1, 2, 0, 0, 1, 2, and 2, 8. And so if I connect my points, you can see that this parabola is skinnier than this one. So a stretch really pulls that parabola up tall and straight, and it pulls these arms closer to the y-axis, which is what you see happening. Now, my vertex I could have figured out without even graphing it. This is my vertex right here at 0, 0. But if you look at this, it's technically in vertex form. There is nothing added inside the function, so that would be 0. And there's nothing added or subtracted outside the function, so that is also 0. So our vertex is 0, 0. And then our axis of symmetry is going right down here through the center of the graph. And the axis of symmetry is the x value of the vertex anyway. So we get two things from the vertex. Thing one is our axis of symmetry, but you have to write it correctly. So since this is the equation of a vertical line, it goes through the x-axis at 0. It has to be written as x equals 0, not just 0. Then the other thing we get is from the y value. The y value of the vertex is going to tell us our maximum or minimum. Because the parabola opens up, I have a minimum value because that vertex is at the bottom of the graph. So it's a minimum value, and because minimum value is based upon whether we're going up or down on the graph, it kind of has to do with range, then we need to look at the y value of the vertex. So the smallest y value of the vertex is 0, or the parabola is 0. So we have a minimum because the vertex is at the bottom of the graph, which equals 0. Then for the point and the reflected point, you can choose any point you want to and its reflected point. So you could choose this point as your point, and that would be the reflected point, or vice versa. You could choose this as your point, and that would be the reflected point. They just have to be equal distance from the axis of symmetry. So I'm going to choose the point 1, 2. Whoops. And so 1, 2's reflected point is -1, +2. Then the other thing I want you looking at is domain and range. So remember, domain is your xy, or your x direction, your right-left direction. So this graph continues infinitely up and to the left and infinitely up and to the right. So eventually it will cover this entire x-axis. So the smallest x value is -infinity to the biggest x value is +infinity. So a spoiler alert would be that the domain of all parabolas that open up or down is going to be -infinity to +infinity. What's going to change is your up-down movement. So I want to go from the lowest y value, which is right here at 0, to the highest y value, which is +infinity. So the range goes from 0 to +infinity. And we include brackets here because 0 is an actual y value of the function. Okay, so let's look at number 2. So this one I want you to graph on your own. Again, we don't have any kind of up, down, right, left motion. Nothing is being added or subtracted inside the function and nothing outside the function. What we have here is a shrink because this is between 0 and 1. So pause the video and go ahead and graph this. It will require a table of values. Okay, so my parent function is here. And so since I have a shrink, the arms of this parabola should get pushed this way. So it's going to get pushed so it's closer to the x-axis. So you're going to see this getting wider. So let's see what that looks like. I can also tell you right now what the vertex and the axis of symmetry are, and whether this is a max or a min without even graphing it. So without graphing it, I know my vertex is 0, 0 because there's no right-left movement and there's no up-down movement. So I can tell you without a shadow of a doubt that the vertex is 0, 0. Now remember, that vertex gives us two things. The x value gives me the axis of symmetry. The axis of symmetry is a vertical line, so it has to be x equals a number, and in this case it's the x value of the vertex. Then this tells us our max or min. Because I know my problem is going to open up, because a is positive, so it's going to open up, I have a minimum value, and the minimum value is the x value, or the y value of the vertex. So in this case, that's 0. So those are the two things that I get from the vertex. Now the point and the reflected point we'll find after we graph it. So I'm going to use the same values because there's no right-left movement as the parent function. So if I put -2 in here and square it, I get +4, and then half of +4 is +2. If I take -1 and square it, I get +1. Half of +1 is 1/2. If I take 0 and square it, I get 0 times 1/2 is 0. So my vertex has not changed. Take 1, square it, you get 1. Half of 1 is 1/2. So there's a reflected point. And then take 2, square it, you get 4. Half of 4 is 2. So let's plot these points. Oh, no wonder that point looked funny. So this point is in the wrong spot. I was wondering why it wasn't flattening out. All right, so as you can see, this is a little fatter, wider than the parent function. Now you can choose any point you want to. I'm going to choose this point right here, 2, 2. So if my point is 2, 2, its reflected point is directly across the axis of symmetry, and the axis of symmetry is right through here. So since this is 2 units away from the axis of symmetry, 2 units on the other side is this point, which is -2, 2. Our domain is the same as I said it would be. All of these parabolas, the domain, so long as the parabola opens up or down, the domain is going to be -infinity to +infinity, because this parabola will cover the entire x-axis. The smallest domain value is right here at 0. I missed that there a little bit, sorry. So our range, our smallest range value is 0, and it goes to +infinity. All right, so let's look at example 3. So, the vertex form of a parabola, making this a smidgy bit bigger. So if you recall, the vertex form was f of x equals a times x minus h squared plus k. So we can get a lot of things from this. If a right here is greater than 0, well, first of all, a is your stretch or shrink. But if a is positive or negative, it tells us something too. So when it's saying if a is greater than 0, then they are looking for, does it open up or down? So this opens up. If a is greater than 0, meaning positive, the parabola opens up. If a is less than 0, then the parabola opens down. Then right here, HK is your vertex. HK, notice that it's not negative HK, it's H. So H is the opposite of negative H. So whatever value is here, if you have a +2, the x value of your vertex is going to be a -2. If this is a -2, the x value of your vertex is going to be a +2. So the H and the K represents the vertex. X equals H is your axis of symmetry. And then if you have an X minus H, remember that's the opposite of what you think it is. So your movement will be right move. And then if you have X plus H, that would be a left move. So what they don't say, and probably should be on here, is that if you have a positive K, that equals an up move, and a negative K equals a down move. And then of course, if A itself, the absolute value of A, not whether it's positive or negative, if A itself is greater than 1, you have a stretch. If A is between 0 and 1, meaning a fraction like 1/2, 2/3, 5/6, that's a shrink. So what I would like you to do here is, we're not going to use a calculator because you don't need one. I just want you to look at these equations and determine, without use of a calculator, what transformations are occurring. So pause the video, write your transformations down. I want you to determine what the vertex is, what the axis of symmetry is, what the max or min is, and what its value is. So all of that without graphing. And then I could even do the domain and range without graphing as well. So pause the video and then we'll talk. Okay, so from here, I can see that we have a right 2 and up 3. So my movement is right 2 and then up 3. That means my vertex is going to be positive 2 because it's the opposite of h, and then positive 3, it's the same as k. From that vertex, remember, I can get two things. From the x value, I get the axis of symmetry. So A of S, axis of symmetry, would be x equals 2. Not just 2, but x equals 2. And then from the y value of the vertex, I can get my max or min. Well, because A is 1 and that's positive, I know that my parabola opens up. So I'm going to put here, opens up. So because it opens up, we have a minimum. And the minimum is going to equal the y value of the vertex. So from that, I can actually do domain and range because I know my domain is always negative infinity to positive infinity. But my range, if I have a minimum value, that means that 3 is at the bottom, so that's my lowest y value. My y value is going to go from 3, and it can only go up from there. And that's it. Okay, so look at B. B does not have a stretch or a shrink, nor a reflection. So all it has is, because of this, it has a movement to the left of 2 and down 3. So let's write that. We've got left 2 and down 3. I know that this parabola opens up because A is positive 1 right here. I know my vertex is the opposite of this and the same as this. So my vertex is negative 2, negative 3. From the vertex, I get the axis of symmetry, which is x equals negative 2. Then I get from the y value and the fact that it opens up that I have a minimum value, which equals negative 3. That helps me with my domain and range. So my domain is negative infinity to positive infinity, as always. My range, my minimum, my lowest value is negative 3, and it can only go up from there. For C, C's got everything you can imagine. So let's just start with the easy part. Right 1, up 2. Because A is negative, I know that it opens down. Since it opens down, that puts the vertex at the top, which makes it a maximum. I also have a stretch of 2 and a reflection over the x-axis. Now the vertex is +1, +2. Opposite, same. From that vertex, I get the axis of symmetry. X equals 1. And because I have a maximum, because this is at the top, I have a maximum value of 2. That will help me with my range. So my domain is -infinity to +infinity, but my range, the lowest value is actually -infinity because this keeps opening down here, so it just keeps going down and down and down. I can't get to my lowest value. So my lowest value is -infinity, and it only goes up to the maximum value of 2. And then D. So for D, I have a left 1 up 2. Then because I have a negative, I know it opens down. Again, giving me a maximum value. Then because 0.5 is between 0 and 1, I know I have a shrink. And because of the negative, I have a reflection over the x-axis. Okay, so the vertex is -1, +2. From that vertex, I get the axis of symmetry. X equals -1. And from here, I have a maximum value that equals 2. My domain is -infinity to +infinity, but my range, like the previous one, this keeps going and going down, so I can't get to my lowest value. So I go from -infinity until I reach that maximum. So -infinity to the maximum, which is +2. All right, the last two questions. Now, what happens if we put a negative? What happens if A turns negative? Well, if A turns negative, then the parabola is going to reflect across the x-axis. So for this one, my parent function used to be here. Okay, so that's where my parent function is. You're going to see it reflecting this way. So the vertex is going to stay there because this is the line of reflection, is the x-axis. This point is going to move here, this point's here, and this point's going to move down to here, and this point down to here because those are equal distances. And so, because we don't have any stretch or shrink, just a reflection. But let's go ahead and do a table of values. Since I don't have any right-left movement, there's nothing happening inside the function, I'm going to use the same x and y value as my parent function. So -2, -1, 0, 1, and 2. So if I take -2 and plug it in here and square it, first of all, this negative is not squared because it's not in parentheses. So it's basically saying -1 times x squared. So -2 squared is +4 times -1 is -4. -1 squared is +1 times -1 is -1. 0 squared is 0 times -1 is 0. 1 squared is 1 times -1 is -1. And finally, 2 squared is 4 times negative 2 is negative 4. So I'm going to plot those. And so this is the graph of the reflection of the parent function. So the vertex is still 0, 0, and again I could have seen that from the equation itself because nothing was being added or subtracted inside or outside. The axis of symmetry I can get from this because it goes straight down here. So this is your axis of symmetry. And so that of course is going to be x equals 0. Remember, I can get that from the x value of the vertex. And then this is going to give me, because I have it opening down, this vertex is at the top, so it's a maximum. And notice that the maximum y value is 0. And that happens to be the y value of the vertex. So then you can choose any point you want to. So I'm going to choose this point right here, negative 2, negative 4. And its reflected point is directly across the y-axis to here, positive 2, positive 4. Positive 2, negative 4. Domain and range. So let's talk about that this time. So your domain, as I said, doesn't change. Negative infinity to positive infinity. The x value is not restricted. But the range, starting from low to high, because we go up, down, the lowest value, since this keeps continuing down, the lowest value I'll never get to, so it's negative infinity. 2, the highest y value is right here at 0. All right, let's look at 4. Now you try 4 on your own. Pause the video. You'll need to make a table of values because there is a stretch and a reflection over the x-axis. Okay, so since there is no right-left movement, I'm going to choose negative 2, negative 1, 0, 1, and 2. I'm just going to plug it in above. So negative 2 squared is positive 4 times negative 2 is negative 8. Negative 1 squared is positive 1 times negative 2 is negative 2. 0 squared is 0 times negative 2 is 0. 1 squared is 1 times negative 2 is negative 2. 2 squared is 4 times negative 2 is negative 8. So the parent function would have been here. So I expect this to open down, be reflected across that x-axis, and not change, well, it will change shape. It's going to stretch, and so it should get closer to this y-axis, so it should look skinnier. Okay, so negative 2, negative 8, negative 1, negative 2, 0, 0, 1, 2, and 2, 8. So as you can see, it definitely got skinnier. All right, so our vertex is at 0, 0. And then this is my axis of symmetry. I could also get that from here, x equals 0. Because it opens down, I have a maximum, and that y value of the vertex is 0. So the maximum y value is 0. I'm going to choose a point, 1, negative 2. The point that's across the y-axis from it, same distance away, would be negative 1, negative 2. The domain is negative infinity to positive infinity. The range, going from low to high, is negative infinity to 0. Oops, I don't want that. All right, let's look at 5. So now we're going to get into some up, down, right, left movements. So because we have a -2 outside the function is x squared, this is exactly as we think it's going to be. And so that's an up-down movement, and so it's going to be down 2. So these are really easy to graph because all I do is I graph the parent function, which by now you should know the ordered pairs, or if you don't, you're just taking the x values and squaring them. So 1 squared is 1, 2 squared is 4. -1 squared is 1, -2 squared is 4. And essentially I'm going to move each of the parent function's ordered pairs down 2. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And that's it. Pardon me. Okay, so I got myself a cough drop. So hopefully I will quit coughing in your ear. All right, so that's our axis of symmetry. This is our vertex. So the vertex has moved down from 0, 0 to 0, -2. So from that vertex, I should get two different things. The axis of symmetry, which is x equals 0, and the max or min. Well, since this opens up, I have a minimum of -2. So that's going to be part of our range because it's a range value. It's an up-down value. So our domain is still -infinity to +infinity, but our range, our lowest range value is right here at -2, minimum -2. So it means we're going to start at -2 and continue to +infinity. Then we need to choose a point. So I don't know, I'll choose 2, 2. The reflected point to 2, 2 would be 2 units on the other side. So -2, 2. Okay, look at number 6. So number 6, I would like you to try on your own. Figure out what transformation is occurring here. Plot the parent function points and move it. Okay. So because we have something being added inside the function, it is the opposite of what you think it would be. So we are going to go left 1. The parent function is at 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. All I'm going to do is move each of those left 1. The shape of my graph has not changed, it just moved to the left 1. And that's as simple as it is. I can read the vertex from there, which is -1, 0, but I could also read it off of, this is considered vertex form. Remember, the opposite of what's inside is -1. Nothing is being added or subtracted out here, so that nothing is 0. Then from there, I can get my two things. I can get my axis of symmetry. This time, my axis of symmetry is x equals -1. Because my axis of symmetry is right here, going through the x-axis at -1. The other thing I get is from the y value. Max or min value, well, this is a min because your vertex is at the bottom and the y value is 0. That's going to help you with your range. So our domain is always -infinity to +infinity, but our range starts at 0 and moves up from there. So 0 to +infinity. So you choose a point. I'm going to choose -2, 1. The reflected point to this one is now no longer across the y-axis, but it's across the axis of symmetry. So this is 1 unit away. 1 unit here would make it 0, 1. Okay. So let's look at question 7. So if you were to graph this, you do have a left movement of 2 and a down movement of 3, but because of this stretch, we're going to need to use a table of values. So because of the left movement right here of 2, I can't use my normal -2, -1, 0, 1, and 2. I'm going to go 2 left of each of those values. So 2 left of -2 is -4. The next, this is my parent function. Okay, the next point of the parent function is -1, 1. So 2 left of that would be -3. And then from 0, 2 left of that would be -2. And then from 1, I'm just looking at the x value, from 1, 2 left of that is -1. And then finally, the x value of 2 to the left of that is 0. So those are the values that I'm going to plug into here. So -4 plus 2 is -2. Squared is 4, times 2 is 8, minus 3 is 5. Then -3 plus 2 is -1, squared is 1, times 2 is 2, minus 3 is -1. -2 plus 2 is 0, squared is 0, times 2 is 0, minus 3 is -3. -1 plus 2 is 1, squared is 1, times 2 is 2, minus 3 is -1. And there's our first reflected point. Finally, 0 plus 2 is 2, squared is 4, times 2 is 8, minus 3 is 5, and there's our second reflected point. So I'm going to plot those values. I should see a stretch going on, although it might be a little distorted because the x and y value on here appear to be not the same distance apart. So it's going to look a little distorted. So then -3, -1. And then -2, -3. And then -1, -1. And 0, 5. Our axis of symmetry would be right here because I like to test the symmetry of my parabola. So there's our vertex. So A is equal to 2. H in this case is the opposite of what we see there, so it's a -2. And K is exactly what we see there, which is a -3. So because my vertex is at -2, -3, remember I get two things from that. I get my axis of symmetry, so that's x equals -2. And then they didn't ask for this, but from here, I get my minimum because the vertex is at the bottom of the graph of -3. So you can choose any point you want to. I'm going to choose -3, -1. So -3, -1's reflected point is right here at -1, -1. The domain is -infinity to +infinity. And your range, your smallest range value is right here at -3, and it goes up from there. So -3 to +infinity. So remember this minimum tells you that the smallest y value is -3, and it goes to infinity. Oh, they did ask for max or min. Here it is. Boop, right there. Excuse me again. All right. So the description of our transformations, we already kind of talked about it, but here they are. Again, we have a left movement of 2 and a down movement of 3. Then we have a stretch, vertical stretch of 2, and that's it. So let's look at the very last one. So let me make this a smidge smaller. Okay. So you are to write a quadratic function to model the graph. So this is one of the harder problems, but once you know how to do it, it's pretty simple. So you have to find the following. So off of the graph, I can see the vertex. So all I need to write a quadratic function is a vertex and one ordered pair on the graph, because then we're going to use this here to find A. So I can easily see on the graph, I can find where the vertex is, and then if I use, remember f of x is y, if I just have any x or y value that's on this graph, I can plug it in here, and that leaves me with only A as the missing part. So right here you can see that the vertex is -2, -6. And what that gives me is h and k. Now remember, h is always the opposite of what it is. And then you can choose any point you want to. I'm going to choose this point because it has an x value of 0 and a y value of 6. I like that point best. So 0, 6. And so this is going to represent our x value and our y value. So we are going to write our quadratic function. So here we go. I'm going to need some room, so let me do it right underneath here. So I'm going to start with y equals a times x minus h squared plus k. So I'm going to plug in for everything except a. So my y value is 6, my x value is 0, my h is a -2, so I want the opposite of that, which is a +2, and my k is a -6, and I want exactly that. So then from here you're just crunching the numbers. 0 plus 2 is 2, squared is 4, times a is 4a. Minus the 6, and then we have a 6 on the left. So then if I add 6, I get 12 equals 4a, and then divide by 4, I get a is equal to 3. So now, in order to write the function, I know that a is 3, and h is -2, and k is -6. So now all I have to do is write the function. So f of x is equal to, instead of a, we're going to use 3 times x, and then I want the opposite of what h is. So since h is -2, I'm going to put a +2 in here, square it, and then I want the same as what k is, -6. And that's it. That's all there is to that. Now you could have chosen whatever ordered pair you wanted for x and y. Now, name the domain range and minimum value. So your domain, as always, is -infinity to +infinity. Now our range, since I have a minimum, that's the smallest range value, so our smallest value starts at -6 and goes up from there. So the range is -6 to +infinity, and since my vertex was -2, -6, this gives me my maximum or minimum value, and since it opens up, that's a minimum. So then we have a minimum that equals -6. That's all there is to it. Good luck on your homework. Let me know if you have any questions.